Hello, everyone, and welcome to Forensics Talks. This is episode 52. My name is Eugene Lisho, and this is the first of 2022. So glad to be back. We had a pretty big year last year with a lot of different episodes. We are live streaming to YouTube, Facebook, and LinkedIn, and now we're also doing some podcasts. Now, I'm taking some of the select talks that I've done before, and we're putting them on to places like Apple Podcasts, Google Podcasts, and stuff like that. You should be able to find it. It's on a whole bunch of different platforms. Now, if you are watching here today, by all means, there's a chat window there. So if you'd like, please go ahead and just type in the chat window. Always interested to know where people are from. So I want to welcome everybody there. And yeah, if you're watching from around the world, always good to know, like I said, what city you're from. All right, just a couple of quick things before we get started here, and just a couple of quick announcements as usual. So let me bring those up here, and we will get started. So the first thing that I wanted to bring up, and that had to do with the Iafsm Conference. So that's going to be at iafsm.org. So that is the International Association of Forensic and Security Metrology, as well as the Association for Crime Scene Reconstruction. They're having a conference in Denver, and that's February 14th to 18th, 2022. They're having a mass casualty exercise. I'll be teaching the basic laser scanner certification course. So a bunch of different things going on there. It's going to be pretty busy and pretty big, but that is definitely going forward. So please keep that in mind. Also, I'm going to be hosting a symposium next week. So that's the Forensic Photography Symposium, and that's going to be all of the next week, January 17th to 20th. If you're interested in registering, just go ahead to the link there, ai2-3d.com/FPS, and you'll be able to get all the information. The schedule is there, speakers are there. It's loaded with information, so hopefully that'll be of interest to you. All right, let me pull that back, and we are going to get started here. So my guest today is Roland Angle, and he's graduated with a bachelor's degree in civil engineering from the University of California at Berkeley, and he's been a licensed professional engineer in California for the past 53 years. His experiences included working on the design and testing of blast-hardened missile launch facilities, construction of flood control projects, design of harbor terminal facilities, design of earth foundation and hydraulic systems, design of U.S. naval explosive containers, ownership of 3 construction companies, and teaching engineering subjects to students. He served in the U.S. Army Special Forces, and he was trained in the use of explosives. He served on the board of directors of AE 9/11 Truth since 2016, where he initiated and led Project Due Diligence. It's an outreach program to the engineering community explaining the reasons why the National Institute of Standards and Technology's reports on the collapse of the 3 high-rise buildings that occurred on September 11, 2001 are deficient. And in August 2021, he was elected to the position of president of CEO of AE 9/11 Truth. And so I'm going to bring him in here. And hey, Roland, hey, welcome. Thank you so much for being here.
Thank you for having me, Eugene. It's a great honor.
Oh, the honor is mine, believe me. And I want to say there is quite of information here today. This interview was at the request of some people actually that were online with respect to the last interview that I did with Dr. Halsey. There was a lot of feedback on that particular talk, tons of comments, tons of views, more than any other interview that I've done. And so it's obviously an important topic. It's a topic that has a lot of discussion points and such. So I appreciate you coming on and responding to a lot of the questions that have come up in the comments. Yeah.
Glad to do it.
All right. Well, first things first, I want to ask you about the young Roland Angle when before you were a professional engineer. Were you the kind of kid that was running around pulling stuff apart, trying to look in and see how stuff worked? Were you always sort of the engineering type?
There was that aspect to my personality for sure. I was taking things apart, trying to figure out why they did what they did and how they worked, and I got into some peculiar situations as a result of that habit. And I didn't understand that had anything to do with engineering. It was just my curious nature as to why do things do the things they do, and how do they do them?
Yeah, no kidding. Well, obviously it led to some pretty big roles over your career. I mean, I was reading your bio, and I mean, you know, Special Forces, you've worked a lot on construction projects, different construction companies and such like that. So I think obviously you have some background in design and building of structures. So I want everybody to realize that, you know, you're not coming at this from from a journalist perspective or something like that. You're actually going to be, you know, from a technical and engineering perspective, which I think is useful. May I ask you, when was the first time that you sort of came to know about World Trade Center 7 in particular?
It wasn't until several years after the event. I was working at the time for a firm in Oakland, California, Jordan Woodman Dobson, and they were big into terminal facilities for container terminals. And I was the head of their civil engineering department. And I was working with some structural engineers, and I think somebody mentioned something about another building that had gone down in at the World Trade Center. And I happened to shortly thereafter hear a radio show. It was on KPFA in the East Bay, Guns and Butter. Bonnie Faulkner had Richard Gage on, and Richard Gage was an architect from the area, and he was saying that there were questions about the collapse of the towers, and that there was another building that came down at that same day. So he was putting on some public presentations on the matter, and I went out to Diablo Valley College one night where he did a presentation, and he made a very interesting case that perhaps the collapse of the buildings was done by controlled demolition. And his evidence was convincing enough to me so that I signed his petition. He had a petition there for people that wanted to ask for a new investigation into the collapse of the buildings. So I signed it, and I indicated on the petition what my profession was, and so on and so forth. So I think that was the beginning for me of an interest in this matter, which of course had significance far beyond just our field of civil engineering and structural engineering. It was a political event and was controversial, to say the least. So I took that into account when I signed my name, because I thought the evidence that he presented was convincing enough to at least call for a new investigation. And I thought that was a very reasonable approach to the question, and was well within the purvey of his expertise and my knowledge.
Right.
So that's when I first became involved. That was my first act.
And you've obviously, you're sort of the top dog now in the organization, so, or one of the top people there. So you kind of moved in and have been working. You began, I mentioned about the Due Diligence Project. So can you tell me about what that was with respect to, and what your efforts were there?
In 2014, after my participation in various activities with the organization, Richard Gage called and asked me to if I would be on the board and the board of directors. And so I said that if I came on, I wanted to lead an outreach to the engineering profession, because I thought that, generally speaking, from what I knew, most engineers were ignorant of the facts surrounding the controversy about the building failures at the World Trade Center. So I said I thought that we needed to go to the rank and file, and I would be happy to lead an effort in that regard, which came to be called Project Due Diligence. We're doing our due diligence to investigate this matter, which we think has impacted our profession and needs to be looked at carefully. So using the petition signers that had been gathered up until that time, of which there were hundreds, I had the staff go through the database, bring up all the engineers, and I selected the civil, the structural, and the mechanical engineers in particular, and contacted them, got on the phone, started calling people all over the country and asking them if they were interested in this subject and if they were interested in helping us get some information out to the rank and file engineers practicing around the country about what this controversy was all about. So, and then I went to, I was given the name of a very influential and important individual in this whole matter, which was Tony Zambodi. Tony Zambodi is a mechanical engineer in New Jersey, and he turned out to be like a librarian. He had all these information on what he had collected, all this information on the actual event, all the reports, all the videos, I mean, he just extensive. So working with Tony, we put together a PowerPoint presentation that covered both Building 7 and the towers. And we put that up on our website, and we sent it out to all of our volunteers, which I had by that time accumulated about 45 engineers around the country. And some of them out of the country, that were interested in taking this information to their local engineering organizations. So we began Project Due Diligence at that time about 3 years ago. And since then, we've made the presentation to almost 1,000 engineers in their professional organizations. That is the local branches and chapters of the American Society of Civil Engineers, the Society of Structural Engineers, the National Society of Professional Engineers, and National Fire Protection Engineers. We're trying to get to as many of those local organizations as we can with our message. And up until this time, we have not had a single engineer in all those presentations, which is almost 40 by now, tell us that that they thought that we were wrong in calling for a new investigation. Mm-hmm. They all agree that there is enough significance to what we're pointing out to indicate that the NIST investigations into those three towers, those three building failures, is flawed. And we need to relook at it. And so we're calling for a new investigation, unbiased. We don't think that NIST is the proper organization to carry it out because they are a branch of the Commerce Department, and that's an executive function of the federal government. And the federal government was involved in this issue. They were responsible for our protection, and that protection somehow failed. So they are not the right body to be involved in the investigation of something that their branch of the government may have had some problems with. We're asking for an independent investigation by something like, we would use the model of the National Transportation Safety Board as an example, right, which was originally under the Department of Transportation, but was brought out as an independent body to prevent conflicts of interest. And we think conflicts of interest are something that need to be addressed at the very beginning of the investigation, so that we can be sure that we get as clear and unbiased opinion on what happened as is possible.
Yeah. Okay. So we're going to get into it here, into some of the details, and I want to lead into it. But very quickly, can you just describe sort of what your main functions and responsibilities are as the president and CEO of 9/11 Truth?
Well, I work for the board, and at their pleasure, I came on in August of last year when the board asked Richard Gage to step down due to some problems that Richard had staying on topic. We had always agreed that we were experts in the field of the building performances, and we were going to stick to that subject, and we weren't going to wander off into other aspects of that day, even that day's events, like the Pentagon and Shanksville and economic issues and disappearance of gold. And there's a whole bunch of other things that are related to that event. But we wanted to stay focused on the engineering aspect of those 3 building failures. And I think over time, Richard kind of got baited into going off into other subjects, and that resulted in the loss of our ability to reach a wider audience. We had a chance to do that with the 20th anniversary. Spike Lee was going to make a film that gave us a chance to tell our story to the whole audience that he would have reached through his HBO platform. And as a result of Richard's remarks about other subjects, that whole episode got dropped, and we lost that opportunity. And the board, we had to be self-critical that we knew that this had been going on for some time, and Richard's wandering off, and so we asked him to leave, and we felt that that was necessary for us to maintain our credibility as experts in the field and not be tarred and feathered with this conspiracy theory label. So that's when they asked me to come on, and so I basically work with the board and work with Project Due Diligence and try to stay abreast of all the lawsuits that we have going on against the Attorney General in Southern District of New York and NIST for their failure to respond to our request for corrections. And the movies that we've made several movies, Experts Speak Out. We've made another movie for the 20th anniversary, The Unspeakable. We have a very great staff of terrific people that work hard and are on top of every situation. And we have 3,500 signatories to our petition at this point, engineers and architects, and we have thousands of supporters. And we have volunteers volunteer researchers that do a great job for us, bring us stuff all the time. And so it's a very complex operation. We're a small nonprofit, but I think we get a lot done, and I'm very, very proud to be associated with it.
Great. Well, in that vein and sort of what you said, I think we're going to try and stay on topic and not try to diverge too much. So one of the things I think we discussed beforehand was just, trying to keep it to the physical evidence, and a lot of the comments, and sometimes people go off into hearsay and he said, she said, or whatever. So I think today is really going to be about 2 main things. One is going to be the NIST report, and the other one is going to be Dr. Halsey's report. So let's start getting into it. And one of the questions, the comments which came through had to do with how Dr. Halsey became involved, how was he funded, and what was the agreement between AE 911, yourselves, and Dr. Halsey's group?
We became aware of Dr. Halsey through the efforts of one of our volunteers who knew Dr. Halsey personally, and we were looking for somebody to do a report on Building 7. We thought it was the most accessible aspect of the 3 buildings that we thought that the evidence was clearest there, and the evidence, the information that we needed to get to that evidence was more readily available. So we selected Building 7, and we put out the word that we were looking for an academic to conduct a study. And our volunteer approached Dr. Halsey apparently 3 times, and Dr. Halsey refused the first 2 times. But on the 3rd time, he decided that he thought that this was an interesting subject and he would look into it. So he was a professor at the time at the University of Alaska Fairbanks. And so he approached the University of Fairbanks and said, these folks want to do a study on Building 7 that collapsed at the World Trade Center on 9/11, and is the university amenable to entering into that kind of an agreement? So he was fortunate that he had a department head that said, yes, we think that's interesting. So our agreement was with the university. In a typical arrangement like this, we give a grant to the university. The university then empowers the professor to go ahead with the study. So our relationship isn't directly with Professor Halsey; it's with the university, and he wasn't paid by us to do this study. We paid the university, and the university paid him his salary to do what he does, which is teach and conduct research. And in this case, the research was into Building 7. So he got a couple of his PhD students to work on the project with him, and they did a lot of the analysis. And so one of his approaches was to run two different computer simulations, finite element models, 101 computer program, SAP 2000, one on Abacus, and that way he could compare their results and see if he was getting consistent answers to his input equations. So that was the way we came into being with Professor Halsey. And I might add that he was not in contact with us in general. He did talk to Tony Zambodi on about some matters, because Tony had a lot of information that he could evidence that he could feed in to Professor Halsey as he began his investigation. But he purposely stayed away from outside media influences discussing the subject, and tried to keep himself focused on the evidence and the facts and how he was going to go about his analysis.
Okay, and fair enough. And I mean, one of the comments, a fair comment, I think, is, hey, you paid the school, and he works indirectly for the school, so is there a potential for bias or something like that? So, and fair enough. But I think the fact that you did go outside and you went through the university, and in speaking with Dr. Halsey, I mean, I didn't perceive that there was any sort of slant or whatever. Although another criticism of Dr. Halsey was when the last interview we did was that he said that he believed early on that fires didn't bring this down, which I think is fair. A lot of people, when they first see the building, when I looked at it, I mean, people have an impression of what they think may have happened or whatever, and so long as it doesn't influence their work, which I think working with a team there, I don't think he did. And in looking, if you read his report, I think it may stand for itself. But do you have any comment on that?
His investigation took him 3 to 4 years, and I think his statement was, as I recall, what his position has been, that after a year or so, when he ran his preliminary studies, he began to see that the notion that thermal expansion caused by the fires could have caused the building to collapse in the way it did. He just felt, based on the evidence that he had, the preliminary studies, that was just not going to work. Mm-hmm. He didn't, I don't think that was a conclusion that he came to looking at the building coming down the first time he saw a video of it or anything like that. I think it was something that he's a very careful guy, as most engineers are. We try to stick to the evidence and to the facts, and not allow our perhaps prejudices influence our decisions. So I mean, if you look at the other side of it, I mean, if you say, well, we're looking at his report and we're comparing it to the NIST reports. If you look at the NIST reports, you see that this was an agency of the federal government that carried out this report, and the federal government was perhaps culpable in the failure to protect the U.S. citizens that day. So I think that that question can be asked on the other side and answered, in the same way. Was NIST? I'm sure NIST made every attempt to be as as unbiased and as factual as they could. However, when you look at some of the decisions that were made, and we'll get into here in a little bit, it makes you wonder how uninfluenced they were when they made those decisions. Because for the life of me, can't see any reason from an engineer standpoint for some of the decisions that they made.
Yeah, no, fair enough. So you know what? Let's start getting into this. And in order to sort of help people out here, I'm just going to do a quick rundown of some slides that I did. And I did this with Dr. Halsey, but I'm going to do it a little bit quicker. And that's just to ground some people in some of the details about the location and layout of the World Trade Center 7, the complex, and its relationship to World Trade Center 1 and 2. So I have some slides on screen here, but basically you can see an image of World Trade Center 7 here. And you can see that it's a trapezoidal building. And on the left image here, we're looking at the south side, and on the north side is the longer side. And so the World Trade Center complex, it was a whole series of buildings in downtown Manhattan. And so the arrangement of the buildings were like you have on my screen. So World Trade 7 was one of the most northerly buildings. World Trade Center 1 is about 105 meters, about 350 feet south of World Trade Center 7, and then World Trade Center 2 is even farther back. So that's the most southerly building of the ones that had collapsed is World Trade Center 2, so the furthest south. World Trade Center 7 was a 47-story building. It was completed in 1987. Excuse me. It's a steel structure with reinforced concrete construction, and it was built above Consolidated Edison. So this is a electrical power substation with its first 3 floors connected to the substation. And when they built the substation, they had intended they had planned to build on top of it. So it's a pretty hefty structure that's on the 4th and 5th floors. So from the 7th to the 47th.
Eugene, yeah. Just a second. The substation only involves the first 2 floors.
I think it's like 1, 2, and 3, but the structure that's above, they built some heavy. My understanding is that they built some. There's additional steel structure there, I guess.
That's
is what
correct.
I'm saying.
Yeah, it goes up to the 5th floor.
That's right. Okay, that's what I meant. But thank you. So basically, that's sort of the building. If we get into the sort of the dimensions here, you can see in a plan view here, it's a trapezoidal structure. The south end here is about 247 feet. The top end a little bit larger, 329. It looks like is what it says. So it's not a symmetrical building. Fair enough, but one of the things that we can look at is that from the 7th floor to the 47th floor, it's supported by 24 interior columns and about 58 perimeter columns. And so we're going to be getting into the columns and such like that. Now, interestingly, part of the design of this structure, part of the design included sprayed fire resistant material. So there was in fact a coating of this stuff that's on there. It's in the design plan, and it appears that it was in the bids for the contractors. And in fact, there is an ASTM E119 standard that people have to adhere to, and actually the instructions to the bidders, and this is coming right from the NIST report. You can read this right in there. But the instructions for the bidders for the World Trade Center job were to bid on a 3-hour rating and a 2-hour rating, and that goes for the columns and the metal deck floor respectively. And so normally the ratings are a little bit less than that. Okay, so it's like a 2-hour and 1.5 rating, so they had to exceed that, and that's all important. And now I think I'll pause there for a moment. And so Roland, let me ask you, I mean, if I'm missing something, or if there's something else that you think is important to mention at this point, just chime in here. But is that a fair assessment of the sort of the building?
Yeah, I believe so.
Okay, good. Now, with respect to the actual structure, or I should say on the layout here, and if let's move into maybe what the events of that day and sort of like what happened, like what's the timeline. And so, that particular day, it started like any normal day. It was actually a sunny day, clear sky and everything. And at 8:46, American Airlines Flight 11 crashes into the North Tower. So that's World Trade Center 1. At 9:03, Airlines Flight 175 crashes into the South Tower. And actually, I think I have another, it's this over here, it crashes into the South Tower, which is World Trade Center 2. And then 9:59, so almost 10 a.m., the south tower collapses. So that's World Trade Center 2, and then at 10:28, the north tower collapses. Okay, so this one goes, and then World Trade Center 1 goes. And with respect to World Trade Center 7, it's damaged by debris from the north tower. So we were talking about 350 feet away, and in the NIST report, it says that debris ignites fires on multiple floors of the building. It talks about 7 pillars or 7 columns, exterior columns being severed, and there is these fires ensue. They grow. They're uncontrolled. There's a sprinkler system in the building, but it's not working. And it's not clear to me if it's because somebody was running a test or if it's because something with respect to the water main on that's tied in with World Trade Center 1 and 2. I don't know, Roland, do you have anything to add to that?
The NIST report says that the sprinkler system for the floors 21 and below was turned off early that morning for a test.
Okay, so it was shut off.
But the upper floors were served, above floor 22, were served by tanks in the upper part of the building. So the upper part of the building had sprinklers and water functioning, and the lower part of the building did not.
Yeah, they had, I think, the floor, there was like a mid-level of 21 through floor 39. They had 2 large storage tanks, and there's some additional stuff that's happening between on the 40th and 47th floor. So for whatever reason, they're saying that, they just burn uncontrolled and it didn't work. So that's what we have. Now, in order to really understand the sort of the contention here between what NIST is saying and what Dr. Halsey is saying, in summary, I'll just say this kind of quickly, but NIST is saying that the debris, and actually they quote it as that the damage done to World Trade Center 7 was caused by, they quote, flaming debris. So they're saying that there's this flaming debris that's coming from World Trade Center 1, and then they say it's induced electrical failures. So there were fires on the southwest side of the building. So if we look at here, this is World Trade Center 1, this is World Trade Center 7. So obviously the debris flying from here is going to hit the south face of World Trade Center 7. And the diagram that I have here shows, and this area in red in particular is where there, I believe, is the damage to the exterior columns. And so, 7 of these things were damaged, or 6, I believe it's 6 actually, that were damaged here. I don't know exactly where, but they highlight this particular area and some other areas of damage. So based on that, that's where sort of things start on its own with World Trade Center 7. So Roland, what I want to talk about the fires, because that's really at the basis of everything here. What is? Let me ask you, is there anything in particular about the fires? You've probably seen some of the videos and you read the reports, but is there anything about this building or about the fires that could have led to this global collapse?
That is NIST's contention, that it was the fires and the fires alone that caused the building to collapse. They said that this damage that you've indicated here was not a factor, and that the fires started by the debris resulted in office fires, what would normally be office fires in the building, and that they traveled around the building from their initiation point in the southwest corner to the northeast corner, where they caused thermal expansion of what turned out to be the longest beams in the building. And that expansion of those beams caused a girder to be pushed off its connection at one of the columns, which led to a collapse of floors. That was supposed to happen on the 13th floor. And that led to a collapse on the floors below it in that corner of the building, which led to instability of the column, which caused it to buckle and caused the adjacent columns in the core to buckle, and then the rest of the core columns to buckle. and then the instability, the collapse of all the core columns caused the perimeter columns to buckle, and that's what brought the building down. So that's their theory.
Right.
And
So yeah,
it's a theory worthy of investigation, certainly.
okay. So and I think this is an important point, because when I had first heard, hey, fires brought this thing down, it's easy to, if you're not reading the report, it's easy to think that, hey, it burned up. It's basically, like it was consumed in fire, and then it just fell to pieces, kind of thing. But in fact, what they're suggesting is that it was not an extreme temperature. It's just that the temperature was sufficient enough to basically cause thermal expansion. And it's this thermal expansion, just the fact of the heating, causes a problem. And some of the things that I'm going to ask you about, or I'd like to ask you about, are the temperatures used in the analysis, because let me ask you, normal office fires, what kind of temperatures should you expect from normal office fires, and were those types of temperatures used, or was there a temperature that was more aggressive or more conservative used? Do you recall what that was?
The temperatures that they used in their analysis to show that their theory was viable were 600 degrees Celsius for the beams that expanded, that they said expanded, 550 degrees for the girder. Now, if you look here at your diagram, we're looking at the 5 beams that frame into the girder that runs into column 79. Look at column 44, mm-hmm. and then column 79. And there's a girder that runs between 44 and 79. And then there's 5 beams that frame into it from the east side, going over to the east perimeter of the building. Those are that beam that frames into right above column 79 there is the longest beam in the building. That's the girder. The girder runs north to south. The beam runs east to west and frames in just above column 79.
Yeah,
east to west.
Right, and that one there, actually, I've got some drawings for it, but we have Professor Halsey's model for it, and this is sort of an important point. And actually, let me bring up something else, because I have a model, and so this may just help to frame things for people. I'm going to bring something up here, which is the model, and I brought this up before. I'm not sure if you can see this or not. I think you can. Let me add it here. Okay. This is just a 3D model of the structure of World Trade Center 7, and this is just for demonstrative purposes. So this is not like all the connections and such are not modeled properly, but just for people's benefit as we get in. This is here. Let me go from the top down here. You'll see it. So this is the south end because it's the shorter end, and this is the north end. And so we're talking about column 79, which is actually in the northeast corner. So if I wrap around this side. And as we get into these upper floors, floor 13, I believe, is the one that was in question. And so as I move in here and we start looking at the columns, let me see here. Oh, I'm too high, I believe. Yeah. You'll see that there's a column here, and it has some connections. So let me just look at it here. And you see that this is one of the main beams here.
That's a girder. That's girder A2001, which is the girder in question.
Correct, and then there's all these other beams here that go into 2001 or whatever. Okay, and so it's basically, this is column 79. So for everybody that's watching, this is the main column that is assumed to be buckling in the NIST report. And the issue with the thermal expansion, if I understand it correctly, is that this girder A2001, as it heats up, you have these beams, and it gets pushed off to the right here. Is that fair to say?
Yes, that's their analysis. Their analysis is that those 5 beams coming in from the left there, heated to 600 degrees centigrade, expanded, and all the expansion in their analysis went to the west. In other words, all the theoretical expansion of those beams pushed the girder to the west. And that's actually a very important point, because Professor Halsey analyzed that system under thermal load and said, in fact, the east wall of the building would not be fixed. The floors would expand in every direction from a center somewhere near the elevators. And therefore, all of that expansion of the beams could not be attributed to the direction that NIST claimed it would be. And therefore, the girder couldn't be pushed far enough to be pushed off of its seat. So that's a major aspect of the differences between the two reports.
Right. It's in.
Is the east wall of the building fixed, and does it force all the expansion of those beams to the left, or does the east wall of the building expand as well and therefore decrease the amount that the girder could be pushed?
Okay. And you talked about the thermal expansion. So basically, and just for people's benefit, if you're looking at this model or this image of the top-down view and with all the columns and everything, you can see that these core columns in the center are here. But basically, if this heats up, what Dr. Halsey said was that, sort of the center area somewhere around all these elevator shafts is the part that's going to stay most stationary. And as everything heats up, it's going to expand outwards towards the exterior of the building. And so one of the things that was brought up here is that, I think it's on this last slide here, maybe. Yeah, so Dr. Halsey, this is the northeast corner in the bottom here, but this area that's surrounded here, they didn't, my understanding is that they didn't model this properly, the exterior. So can you explain what happened there?
NIST didn't model the entire floor. They're in their progressive collapse. They're talking about a progressive collapse. So let's talk about progressive collapse. What that means is that they're saying the beams expanded, pushed the girder off the seat, the floors collapsed, the column was left unsupported for 9 floors. It was too slender. It buckled. That caused the adjacent columns on the east side of the building and the core to buckle. The buckling of those 3 columns in turn led to the buckling of the remainder of the core columns, traveling from east to west. Mm-hmm. And then the collapse of those core columns, the 24 columns in the center, caused the exterior columns to collapse, and that led to the global collapse. Now, that's what's called a progressive collapse. In other words, one thing led to another, led to another, led to another. It's a domino effect. So that's their theory, that this progressive collapse led eventually to the global collapse of the building. Okay. Now, when Professor Halsey looked at their modeling of the 13th and the 12th floors, he saw that they only modeled the connections inside the blue area, that is the east side of the building. And they did not model the connections in the remainder of the building on those floors. And he said that those connections would in fact affect the way the building behaved. So that was one of his disagreements with their model.
Okay, interesting. And I think it's important to note also there's an issue around the design of the column and the girder, right? The A2001 girder, and where they meet and their connection. So again, for people's benefit, if you're looking at a top-down view here, this would be column 79 in the center, and this girder, this would be girder 2001. So the northeast corner would be to the top right of the screen here, relatively. And I think one thing that's important is if you see it, almost column 79 has these protruding sections here on the sides here, and that was an important point because I believe there are some design issues. And so let me go to another view. This is from Dr. Halsey's report. Can you comment on the design, what Dr. Halsey modeled in his report versus what NIST modeled or used in their report with respect to the connection here of column 79 and A2001?
Yes, the plates on the side that are welded to that column protruded past the edge of the column the member by about 1 3/4 inches, 1.8 inches, I think was the exact. And so when the girder is heated to 550 degrees centigrade, as indicated in this model, that girder would also expand. And that would push it up against the face of column 79 and column 44 on the other end.
Mm-hmm.
So even though there was space there in the construction when the whole assembly was put together, the expansion of the girder under the effect of the temperatures would push it up against the face. And then if in fact the girder was being pushed to the west, according to NIST, the edge of the girder flanges would be caught behind the side plates on the column, so that the girder could not be pushed far enough to escape the seat below it, and it couldn't fall. So that was a problem. Apparently, in the NIST connection, in the NIST analysis, they left the side plates off. Now, I'm what you're focusing on there is stiffener plates,
Mm-hmm.
and the stiffener plates were another issue. There were stiffener plates that were welded to both sides of the girder, where connected to the column, and those stiffener plates would have stiffened both the web, which is the vertical part of the girder, and they would have also stiffened the lower flange, which is the horizontal portion of the girder, because it was welded to both the horizontal flange and the vertical web. So when NIST did their analysis, they left that stiffener off. And they said that by leaving off the stiffener and by leaving off the side plates on the column and by pushing the girder all the way to the west, those three factors were what enabled them to make a claim that the girder was pushed off of its seat. But in fact, none of those things are possible. First of all, because the east wall of the building is flexible and the beams wouldn't have pushed the girder as far as they said it was. Secondly, because the side plates on the column were in fact there, and the heating of the girder would have trapped it behind the side plates. And thirdly, because the stiffener plates were there, and the existence of the stiffener plates would have stiffened the lower flange of the girder so that it wouldn't have curled up and allowed the girder to fail. So there's three reasons there why their model does not conform to what we know to be the facts. At least the existence of the side plates and the stiffener plates was a fact. And we know that from photographs, from construction documents. And actually, NIST even admitted that they left off the stiffener plates at the girder, but they made the claim that that didn't make any difference, that wouldn't affect the behavior of the girder in its travel off of its seat. And we know that that's not true from basic mechanics of materials. And furthermore, when they sent us that letter, it was signed by somebody in their public relations department who didn't have the necessary qualifications to be even making that statement. So nobody in the engineering staff at NIST would take credit for that kind of statement, which I think is indicative of the weakness of their position.
Okay. Well, this is from Dr. Halsey's report. So he's tried to model it as accurately as possible. So there's obviously a problem with the design that, or there's some issue of contention with the design that NIST used. Can you talk to me about the beams and their connections? Because this is a steel, lattice of beams and girders and everything else, and then there's a like a composite floor. It's steel with poured concrete. There's like mesh inside, and then there's like studs and stuff. So these are all connected. Like they're all connected together, correct?
Yes, you want them to act as a unit.
Okay, and so in the again, I just to answer some of the questions that came up, but to answer the question about what the difference is between what Dr. Halsey is modeling versus what NIST is modeling, what are some of the differences between the basic design and the basic mechanism of how things were connected or not connected between the two? Can you comment on that?
One big difference was the fact that NIST, if we look again at the girder A2001, running between column 79 and column 44, there were shear studs, what's known as shear studs on that girder. There were shear studs on the beams as well. Shear studs are like bolts that are stuck and welded onto the top flange of the beam or the girder, and they protrude through the metal corrugated pan that the concrete is poured on with reinforcing steel in it. So the purpose of the shear studs is to enable the steel frame to act in unison with the floor plan and with floor pan and the concrete and steel in that floor pan. So it gives it stiffness. Now, in the NIST analysis, they claimed that there were no shear studs on the girder between column 79 and column 44. So that would enable, leaving those shear studs off would enable the beams to expand further, because they wouldn't be as stiff as if they had been connected to the floor pan and its concrete and steel.
Right.
So that was an important difference in how the thermal expansion of the steel frame was going to behave. And again, the drawings clearly show that the studs were there. And so again, it seems as if the difference between the UAF study and the NIST study, the differences with the NIST study always enable their model to work. In other words, the beams all move to the west. There's no side plates on the column. There's no stiffeners on the end of the girder. There's no shear studs on the girder. All these things make their theory seem more plausible. But when you actually put the information there that comes off of the design drawings and the construction photos, you have to put those things in there. You can't simply dismiss them or pretend that they weren't there.
Yeah, interesting. And I should mention too, I was reading through Dr. Halsey's report, but I will verify this because this was a question, and that is that because it comes up, but Dr. Halsey used the same temperatures as NIST. He actually used their temperatures, from what I understand, in his report. So he's not making up his own temperatures, or he's not using something different, but he's actually using the same temperatures. Is that true?
That's exactly true, because he wanted to see if he could use the same input values and the same information on the temperature and the thermal expansion that would replicate their results. The problem was that when he began to build his model, he realized that there were assumptions made in the way their model behaved that he couldn't reconcile. The east wall of the building would not remain rigid. The side plates on the column were there. The stiffener plates on the girder were there, and the studs on the girder were there. He couldn't simply follow this example in that regard, because the drawings showed, and we had all the evidence to show that those features in fact existed.
Right. Let me ask you. So let's assume that, and I believe in both NIST and Dr. Halsey consider the case where, okay, let's assume that A2001 here falls off of column 79. So basically, I believe this is on like floor 13, and basically, let's say it falls off and the floor collapses. And am I correct in saying that that's what they believe happened? Like the floor collapses, right?
That's what NIST proposed, that once the girder was pushed off of its seat, that it fell, and the entire northeast portion of the floor on the 13th floor collapsed down and hit the 12th floor below.
Okay, so what discrepancies do we have between what Dr. Halsey is saying versus what NIST is saying with respect to the collapse of the floor and how that was modeled and the kinds of forces that are there? Is there sufficient force for the floor? I mean, it's concrete and steel, so is that enough to break through, the floor underneath and several floors underneath it?
Well, that's the next question that he addressed. He said, "All right, let's assume that somehow the girder did come off of its seat. I don't think it possibly could have, but let's take it from there and see what happens." So he allowed the girder to fall, and then we looked at what was the impact of the 13th floor hitting the 12th floor below. And what we found was that the calculations that they used for that impact were wrong, because they didn't take into account the fact that it wasn't a point load. It wasn't just the weight. You can't just take that weight and apply it as if it were a point load on the 12th floor below, because it is a falling structure that has a natural frequency. The beams and the girder act as a unit, and they're hinging down from the north face and the east face of the building, according to the NIST model. And therefore, you have to come up with an impact force that's consistent with that model. It's an impact caused by one system, the 13th floor, hitting the 12th floor below. What we found was that their analysis was way exaggerated in terms of the force. We found that the force that girder would hit the 12th floor below was only about 1/10 of the force that was needed to break it loose, to break the 12th floor loose, because the 12th floor has to be broken loose from its connection at column 79 as well. As we can see, it's if you look at the picture you have up there now, the connection on the 12th floor below was exactly the same as the 13th floor above it. So what you have there, you see a plate that's welded underneath that seat to the side plates, and those welds there have to be broken before that connection can be broken and allow the floor to collapse. So you can calculate what that force, that necessary force, is to break those welds loose. And what we found was that you only got about 1/10 of what you need. The NIST analysis failed to take that into account, and their analysis assumed that it was a point load and not a collision caused by the beams and the girder falling on it from below. The 13th floor girder is going to deflect when it hits the 12th floor, and that deflection is going to lessen the impact force on the 12th floor below, and therefore the calculation that they made of that force was incorrect. And we found the UAF report said the 12th floor isn't going to collapse. And therefore, if the 12th floor is not going to collapse, you're not going to get a cascade of floors all the way down to the 5th floor. And the analysis that says that column 79 is going to be too slim because it's unsupported for 9 floors doesn't hold, and it's not going to buckle. So there's another problem with their progressive collapse, that the next item in their progression is not going to work either, even if you discount the earlier ones, which would have prevented it from happening anyway.
Yeah. So, and you can see how, you kind of see where I'm going, because things are beginning to diverge more and more. Obviously, a few little changes in the components and, in your initial conditions, and then all of a sudden the two simulations and the models, they start to diverge rapidly, where, NIST is able to get something to happen that Dr. Halsey can't get to happen. And so, at this point, I would say Dr. Halsey's report stops because he can't get it to do what NIST gets it to do. But let's just, for the sake of argument, let's continue on with what NIST is proposing. And let's say that, I think what they're saying is that column 79 is now unsupported. There are several floors that have collapsed, and that now column 79 can buckle. And I believe that's what they're suggesting. And that column 79 buckling causes the subsequent columns and girders and beams and everything else to slowly, basically unravel. That's the only way I can think about it, is where they're just breaking and breaking apart, kind of like, you take a thread and you just, undo the seam. You just keep pulling and pulling, and then it just starts to come apart. How plausible is that, based on just what we've seen in the past? I mean, would that be a highly unique scenario? Is this something that we would be concerned about as a new phenomenon?
That's what NIST said when they released this report. They said this was unprecedented. This was unique. This was one of a kind. There had never been anything like this before. So obviously, when you make claims that are unique and never before seen, you have to have a justification that is going to be pretty ironclad. And I don't think their analysis, in fact, Halsey went on and he said, okay, let's take the next step. Let's let column 79 buckle and see what happens then. He tried to follow this all the way through to the end. And what he found was that even if you buckle column 79, if you go back to the floor plan now, if we can just see the layout of the columns. Okay, so let's look at column 79. If we allow column 79 to buckle between the 13th floor and the 5th floor, then that in turn would bring down column 80 and then column 81. And then, this is according to this model, then the buckling of those three columns spreads from west to east throughout the core. And then 76, 77, and 78 go down. 73, 74, and 75 go down. 70, 71, and 72 go down. And so on across the core of the building from west to east.
Wow.
From east to west. And so that analysis, when Halsey followed it, what he found was that after 76, 77, and 78 go down, then the rest of the exterior columns, 35, 30, 28, 26 in the southeast corner of the building around there, they would be overloaded and they would buckle. And then the building would collapse, but it would fall over to the southeast. So even if you allowed for all their discrepancies up until that point to occur, and you tried to make the building collapse in the manner in which they said it did, it doesn't fall straight down because the columns on the east and the south side of the building become overloaded and the building fails, falling to the southeast. So he couldn't get their model to work at any level, from initiation to final collapse.
When we look at the actual collapse on video, and I'm just going to play this here, just let it run here, but you can see that, I mean, when I look at this, and it's just an observation, and yeah, I can see that the penthouse, there's this penthouse up on the top, and the interior, it does fall, and then you've got about 6 seconds or something like that, and then the whole building comes down. And so me personally, I have difficulty with that whole building coming down. And just like you said, like, why isn't it tilting to one side, or why don't we see damage, the tilting sort of on side when one side is completely intact? So, and I mean, even looking at this, you can see on this side here, there are no fires right now at this point. You can see all the smoke is from the other side, or at least one side. So, but you can see this comes down, and what does it look like? I mean, if you look, you can go on the internet and look and do some searches and find, what makes a building behave like that. So let's talk about free fall for a second. And what's the importance of free fall?
when NIST issued their preliminary report on this building failure in, I think it was August of 2008, there was one of the researchers that was working with us at that time, David Chandler, who was a physics teacher, had analyzed the collapse, and he wanted to see how fast it was falling. So he used a video technique that enabled him to measure the acceleration and the velocity of the building as it came down. And he discovered that about 3/4 of a second into the movement of the roof, it fell at free fall acceleration for about 2.5 seconds. And he pointed that out to them when he commented on the issuance of their preliminary report. And they acknowledged it. NIST acknowledged it and said, yeah, it's falling at free fall for about 2.5 seconds there, 2.25 seconds, something like that. But they never addressed the implications of what that might mean, because we know that from a physics standpoint, you can't have free fall acceleration unless you have no resistance. So the question then becomes, in a progressive kind of analysis that NIST presented, would you ever have free fall? And the reality is that you would never have free fall, because there's always some columns resisting your fall, the descent of the building. So you can't have the two things. They can't coexist.
Mm-hmm.
You either have no resistance or you have resistance. If you have free fall, you have no resistance. If you have no resistance, then there's no columns there resisting. So, the failure to address that kind of fundamental problem with their analysis is another thing that we see. We say that this question has, your model has to explain reality. If there's a question like that, you've got a serious problem. It's a fatal problem.
Does the fact that because the penthouse does fall earlier, like 6 seconds earlier, does that matter with respect to the free fall? Because they do have I'm just looking for it now. I'm trying to see if I can find it. I don't have it handy, but it's in one of in their report where they basically show the curve, and there's like you said, there's a period where the building falls free fall, but of course there's several seconds before that where you can see the penthouse falling in on itself or inside the building. But is just I guess what I'm asking is just the fact that it falls at some point at free fall enough to say there's a problem?
Yeah, that's enough.
Okay.
The question about the East Penthouse is an interesting one, because the primary column that was supporting the East Penthouse was column 79, 80, and 81. Those are the three columns underneath the East Penthouse. So column 79 was in fact the most heavily loaded column in the building, and 80 and 81 were closely behind, because the equipment in the East Penthouse was very heavy. So when the East Penthouse falls through the roof several seconds before the building starts to come down, that's an indication that columns 79, 80, and 81 must have failed, because that's the only way that penthouse is going to move separately from the building itself.
Mm-hmm.
So we know that those columns came down first. Now, here's another interesting fact. When you look at controlled demolitions of buildings, having penthouses on the top with heavy equipment is not an unusual occurrence. That's a very common place for them to place their HVAC equipment and other equipment that they need near the top of the building for some reason. So if you look at these controlled demolitions, it's often done by the experts that bring these buildings down, that they take out the columns underneath those heavy penthouses. Let's call them penthouses for that's the term that they use.
Mm-hmm.
Take out the columns high up underneath those penthouses, bring the penthouses down into the frame of the building before you bring the building down. Because if you're timing of your explosives is slightly off and the building tilts a little bit and you have a heavy weight at the top of the building, that's going to increase the tendency of the building to fall over sideways. And typically in controlled demolitions, you don't want that to happen, unless you want it to happen for some reason. But if you're trying to bring the building straight down, you don't, you try to account for the fact that maybe that heavy weight on the top of the building could be a problem for you. Okay. So it's not unreasonable to assume that if that was a controlled demolition, bringing the east penthouse down through the roof first was a consideration that was designed to make the building fall straight down.
Okay. Well, we're talking about demolition. And I mean, when I look at this building, so one of the exercises that I did was to go through the internet and look at a number of demolitions and look to see, what, like walks like a duck, talks like a duck. So I'm looking at this from different perspectives. But I also looked at what happens when demolitions go wrong. And that was kind of interesting too. So for example, if the explosives don't go off properly, and let's say, for example, like we have a condition where only half of the building or part of the building gets demolished, the building tips, right? It falls over. And that, I thought that was kind of interesting, because if in fact, column 79, 80 in that area, they actually do fail, how come we don't see this, how come we don't see this tip like some of the other buildings too? But let's assume that this is a controlled demolition. How come we don't hear any sound? And this makes a good point. They say, if this was a controlled demolition, there, you should be hearing blasts and noise from all over the place. And they said, there was no evidence of that.
Yeah, I think that's a question that is of some significance. First of all, we have videos that show, for instance, there's one very well-known one, I think, with you've got two firemen that are being interviewed after they've exited the towers, and the towers have come down. And as they're speaking, there's a blast that occurs, and that blast must have come from building 7, because 1 and 2 were already down. So just because there weren't a lot of blasts, or let's accept the proposition that there weren't a lot of blasts heard when building 7 came down, doesn't mean that there couldn't have been explosives in the building, because those explosives could have been set off earlier, and there were more than 100 accounts of people saying that they heard explosions that day. People saying there were other bombs in the building, there were other explosions. NIST tried to play that down and say there weren't any. John Gross, one of their engineers, actually said at their conference, well, we have no evidence of explosions. But there were recordings of explosions. And then there's the question of, they said that they weren't going to investigate explosions because the noise of the explosions would have been so loud it would have blown out windows 10 blocks away or something like that. But nanothermite, which is the kind of residue that was found in the dust, doesn't necessarily require explosive content, because you can mix it with other substances like sulfur and get thermate, which gives you explosives, or you can formulate it in such a way so that it just cuts and it doesn't explode. You don't get the explosive wave that you do with the organic substance in there. So you can cut these columns and beams with cutting charges without any noise. So for NIST to say that they're not going to check for explosives, which they didn't, because they said there was no sound of explosives sufficient for them to carry out that investigation, is a non-starter, because nanothermite can be used to cut without any significant sound whatsoever. And that would be sufficient to cause the building to fail. And the explosive charge could just be the final touch. In other words, you cut it 90% of the way through the connections, and then the last blow that you give it is just to knock those connections loose and cause the building to come down.
I see. Well, look, we're getting on in time here, but I want to ask you about What has been NIST's position on all of this, and sort of to the reaction of your organization, and what has been the transactions between yourselves and NIST?
When we published the UAF report, we opened it up for comments for a period of about 6 months, and we invited academics, people off the street, NIST, whoever was interested in this subject to please comment. We didn't get any comments from NIST. And I would think that that would be their opportunity to take exception to the findings of the Halsey report. So after we went through the comments, we made some changes. None of them were substantive, but there were some comments that were useful.
Can I ask? Sorry, I don't mean to interrupt, but one of the questions was actually who peer reviewed the Dr. Halsey's report. So can you comment on who not specifically, but the kind of people that did the peer review, and can you say how many might have peer reviewed?
We got two peer report reviews. One was from a professor at a Canadian institution, and one was from a professor in Australia. Both of them structural engineers teaching in the subject. So those were the peer reviews, and we were hoping that if NIST would respond, we would count that as a peer review. I mean, we were looking for peer review. We were looking for comments. We sent out the report to every engineering department in every academic institution of note in North America. We didn't get back one response. We took his report to the University of California, Berkeley, because that's where I graduated, and we presented his report at the faculty club and invited the entire faculty of the civil and structural engineering departments down and all their students to come and hear his report and give us any feedback or input. Not one professor showed up. So the silence from the academic community on this subject is rather deafening and quite telling, I think, because this is not just unfortunately, this is not just a civil engineering matter. It's a political matter. It affected the entire world in one way or another, and people are afraid of it. They're afraid to weigh in on it. But it's significant, I think, that if they had any arguments with Professor Halsey's conclusions, they certainly had the opportunity to make them, and they could have discounted his conclusions on the face of it, when the report was issued, and they didn't do so. So afterwards, we went through his report and the NIST report, and we said, look, there's a number of problems here, obviously. I think we listed 8 of them. And we submitted a request for correction to the NIST, which you can do under the law. I mean, the agencies of the federal government are bound by law to submit accurate and truthful accounts of their activities. So we submitted a request for corrections. They waited till the very last day of the time limit that's allowed for them to respond, and they responded and just reiterated their original positions and didn't address our points at all. So now we're taking them into court, and we'll see if the court will force them to respond in a meaningful way to our request for corrections. So that's where we are with NIST.
Okay. And in terms of information, like in terms of getting any information out of NIST, I mean, there's their reports, but is there been any cooperation at all, like to give you guys some additional information or anything like that? Or is it all just, it's locked away somewhere?
The only thing that they've done is they've responded to our requests by denying them. I mean, we asked for their computer models that they use for the towers, and the director, Patrick Gallagher, responded by saying they weren't going to release them because release of that information could be a threat to public safety. Now, I don't understand how the release of information about the physical characteristics of their model would characterize anything like a threat to public safety. In fact, quite the opposite.
Yeah.
But again, we have the response to when we pointed out the stiffeners were missing off the girder. We got a response from their public affairs department. They did admit that they did have the details wrong on the seat for girder 2001. They had it listed as being 11 inches wide, and we pointed out that the drawing showed it was 12 inches wide, and they did admit to that. That was the one thing that they admitted to that they had made an error on.
Okay. I mean, interestingly though, if this is in fact, as they say, where this new thermal expansion phenomenon can allow progressive collapse, and I don't know if Richard Gage or somebody else had alluded to this, but shouldn't the structural engineers and the architects and civil engineers be up in arms saying, hey, what the heck's going on here? Because it was built to code. I mean, everything that I can see is that the building was structurally sound, the fire sprays on there, all the other stuff was there. But if this thing can collapse like that, based on the design of the day, there must be other buildings that have a similar design or structure, and that could be under the same influence. So you would think that for the reason of public safety, they would want to get something like that out to the public or make some recommendations and such. Were there any such recommendations on new design or I don't know, fire safety or anything like that with respect to what came out of World Trade Center 7?
There have been some things. I mean, there have been some code changes. And there have been groups within the ASCE and within various code, the ICC, and they have looked at these issues, and they have made some code changes. But as far as we've been able to tell, none of these code changes have been substantive in addressing the problems that the NIST report brings up. In other words, I haven't seen any code changes that would say eliminate the kind of connection that occurred between girder 2001 and column 79. Is that sort of a connection deemed to be, somehow too risky now or too dangerous, or can only be allowed in certain conditions when thermal expansion has been taken into account, and so on and so forth? Those kinds of structural issues, to my knowledge and to the knowledge of anybody that I've been in contact with, and we've looked for these things, has not been addressed. And so I don't think they have begun to look at something they call, what do they call it? They've gone into the federal building code, and they beginning to look at situations where a progressive collapse could be initiated by certain types of connections, not taking into account the fact that if that connection failed, what's its effect on the connections nearby, and so on and so forth. So there is a study group that's looking into those possibilities, which I would take is an outgrowth of the building failures at the World Trade Center. But I think it's more in the nature of, I would look at it as more like a CYA, you know what I mean? Cover yourself to make sure that it looks like you're doing something that's meaningful. But in fact, if the whole theory about how those buildings came down is not meaningful, looking into questions that might have caused them is also not meaningful.
Yeah, I understand. Yeah, I do. I understand. What is next for you and the organization? I don't know if there's anything you can talk about in the future. Like, are you planning some other things this year with respect to, I don't know, getting people together, conferences, presentations, virtual meetings, other research maybe, or do you have any other people looking at things, future types of analysis and things like that?
We would like to come up with an analysis similar to the one that the UAF did for us for the Twin Towers. We don't have such an analysis. And by the way, NIST doesn't have such an analysis either that they're releasing to the public. Their report on the collapse of the Twin Towers simply says that once the initiating events occurred, the towers collapsed. They don't give any explanation for it. They just rely on a theory that was put forward by Professor Zdeněk Bazant that was published in the Journal of Engineering Mechanics several months after the event. And they say, well, we see the buildings fell down, so therefore we don't need to explain it. That's not adequate. And the problem for us is getting hold of the drawings and enough of the documents to construct a model. And the building documents for the towers are largely kept secret. I mean, we've been able to get some of them, but getting the rest of them has been proven difficult. And so we've formed a committee, and we would like to investigate and conduct a model of the collapse of the towers, because we think that would be very instructive. And we think it would be helpful if NIST would release their models so that we could have something to run our model against, just like we did with Building 7. Unfortunately, they have refused to do so. So we're going to continue in that vein. We'll continue pressing. Maybe we'll be able to get the drawings from somebody else, and we can proceed along that line. The other thing is that we want to continue our project due diligence to the engineering community, and we've reorganized that. I was in charge of that before, but now that I've taken over as president and CEO, we've reorganized that. We've spread that responsibility out amongst a number of our volunteers. We've got about 24 engineers that have volunteered to make those presentations. We've got a committee set up to organize those presentations. And we're up against, again, the leadership of the professional organizations is discouraging their local chapters from talking to us. So that turns out to be quite a job, just contacting them, following up, finding local organizations that are willing to have us, and then organizing the presentation itself, and using that process to put pressure on the leadership of our national organizations, because they are actually the roadblock at this point. If they came out and said a new investigation was necessary, NIST would have to pay attention to that. But the fact that NIST can say, well, the professional organizations are standing by our report, therefore there's no need for further investigation. So we've really got an internal problem with our professional organizations, particularly the ASCE, because they were heavily involved in the examination of the evidence and the original FEMA report, and they also were heavily involved in the NIST report. So we've got a problem within our organizations, and we also need to reach out to the public, and that's why we're making these films and trying to give the general public an idea of what's going on within our profession, so that public pressure will ultimately, I think, be the decisive factor. You need to have an overwhelming majority that are demanding a change. Mm-hmm. That's what brought about the NTSB creation. I don't know if you know that history. I didn't know it until recently, but
no. There
was a plane crash in 1931 that killed the Notre Dame coach, Knute Rockne, and the plane malfunctioned and crashed and killed everybody on board. And the result of that was there was a national outcry. He was such a beloved figure that there was a national outcry for safety on the matter of plane crashes. And up until that time, the Civil Aeronautic Authority agency had been responsible for investigating the crashes, but there was some conflict of interest there. So long story short, the end result of that was that the National Transportation Safety Board is an independent organization. It's not under any executive branch of the government. So the hope there was that you could get a realistic and honest assessment of what went wrong. And I think that's what needs to be done in this case as well. We need to have an independent assessment, and we're calling for an independent investigation. That's the only way we're going to ever hope to get to the truth of this.
Yeah, and regardless of which side of the fence you're on, I mean, when you look at the conflicting, evidence, reports, and things like that, it's really interesting, to see, because there's a lot of different questions, and at the very least, people should be asking questions. I mean, there's a lot of questions on both sides. Why did this happen, or why did that happen? So, I hope, and I realize it's a difficult subject for some people, and I can understand the hesitancy of, organizations wanting to get involved and maybe being criticized for, I don't know, being a fringe group or something like that. Whatever, I don't know, whatever it might be. But I understand. At the same time, though, I think there's a lot of good questions here. It's a really interesting topic, and I want to ask you, if people want to get involved, or they want to know more, what's the best way to reach out or to contact you or whatever? Is it just through the website, or what is it?
There's a place on our website. It says "Get Involved." There's a drop down that says "Get Involved," and you can click on that. You see at the top there, "Get Involved," and you can sign the petition, and you can volunteer. If you go over to the left, you'll see volunteer. Now, we have a very capable individual, Andy Steele, who's in charge of our volunteers. And without our volunteers, we wouldn't be anywhere. We owe everything to them. And so there is a way that people can get involved. And you never know what it is that you know, or what it is that you can do that might be helpful to us. And without, as I say, I can't emphasize it enough, without the efforts of our volunteers, we wouldn't have gotten any of this done. We're basically largely a volunteer organization. We have many dedicated volunteers that have spent years and years and years doing, I mean, really important and necessary groundwork that has laid the foundation for what we've been able to accomplish. So I would highly encourage people to check it out, see if there's something that you can do that is going to be helpful to us. And of course, you can always donate money. We depend entirely upon donations for our finances, and we have no ties to any agencies or any interests that would maybe have an axe to grind in this situation. So there's lots to be done, and we're tiny, but we're strong.
Well, you've been around for quite some time, so definitely a resilient group. So that, good on you guys. Well, look, Roland, thank you so much. I appreciate your time and your input. You're very, how can I say this? You seem very down to earth and very reasonable and very knowledgeable on the subject. So, wish you guys all the best, in your efforts and everything else. And I really appreciate all the detail and info. It certainly opened my eyes, and I hope that some of the information you brought forth here is going to be helpful to some of the viewers. So thank you very much.
Thanks again, Eugene. It was my pleasure and honor.
All right. Hey, hang back for a second, and then I'll be right back.
Okay.
All right. All right, everyone. Well, that does it for this one. We went over. This is one of my longest ones. Just a lot of material to cover, and if you do want to find out more, or you're really interested in the different types of reports, you can probably search these for yourself. But what I'm going to do is, just before I hang up here, I'm going to put in the link to the NIST report, and this way you can, for yourselves, just kind of look and have a read. And it's not it's something you're gonna have to kill a Friday night doing this. So I'm going to go ahead and put that in there. And the other one that I'm going to put in is Dr. Halsey's report, and that one I think is a good one too. It's also quite beneficial and informative. So by all means, I'm going to just drop that in there. And there you go. That's in the chat window now, so that should be permanent there if you want to go pick it up, but you can always look at it online. So that does it for this one. Hey, look, everyone, thank you very, very much. Appreciate it. Next week, I'm not going to be around. The week after, we're starting up again. I've got the Symposium, Forensic Photography Symposium next week. So we'll see you shortly. I wish you all a very good day. Bye-bye.